Hello students, today's agenda is to check homework. We'll start with a warm-up, then we'll learn radical equations and you will be able to do 5.2. Today students will be able to solve radical equations with variables under multiple radicals and solve radicals equations with variables inside and outside of a radical. So for the warm-up, it says solve, and whenever we have a square root, the opposite to cancel it is to square that. But if we do it on one side, we have to do it on the other. The square root cancels with the square, and we get x is equals to 3 squared is 9. Now, and wherever we get a solution for a square root, we have to check to make sure that that's not an extraneous solution. So we substitute the x by 9. The square root of 9, is it equal to 3? And the square root of 9 is 3, so yes. 3 is equals to 3, so we say that that 9 is a solution. Number 2, in here, when we have the square of a variable, the opposite is to cancel with the square root, but if we do it on one side, we have to do it on the other. Now, from previous lessons, if you recall, whenever you're taking the square root, we always get two possible solutions. So the square root of 9 is 3, but not only positive 3, also negative 3, because negative 3 times negative 3 is also positive 9. Okay, so you get two solutions when you cancel by taking the square root. Number 3, the opposite is to square, the opposite of square root. So that's why they cancel, and you get x is equals to 9 squared means 9 times 9, which is 81. Again, we have to do the checkup test to make sure. And so the square root of, instead of x, we put 81. Is it equal to 9? The square root of 81 is 9, which is equals to 9, so we say check. So it is a solution. For number 4, if we're taking the square root of x, the opposite is to square that. If we do it on one side, we do it in the other. And so x is equals to 0 squared is just 0. Okay? And if we had to check, substituting the square root of 0, is it equal to 0? Well, the square root of 0 is just 0. So we say check. In here, oops, we take the square root of both sides. This cancels and you get plus minus. And since we can't take the square root of 3, we just leave it as square root of 3. Unless if you have to get decimal form of it, then you just use your calculator. And again, remember that sometimes for some calculators, first you put the number and then the square root. For others, you put the square root and then the number. So check which kind of calculator you have. So 3, take the square root and, oops. So we press 3, the square root, and is 1.73, okay? If we round to the hundredths. So we'll leave it like this for this one, but know that you can get it in your calculator. Square root of x squared to cancel the square, so x is equals to plus minus 0. Again, it doesn't make any difference because you're adding or subtracting 0, will not change anything. So in the warm-up, we noticed that the opposite of the square is the square root, and so that's what we have to remember that. So in here we have, it says variables inside different radicals, and so we have to cancel first that radical or square root, and we do that by squaring both sides. Remember that if you do something on one side, you have to do it on the other. And so this radical cancels with the square, and we end up with 3y plus 2 equals. In here, this will go with both the exponents of each one. And so in here is, if there is nothing, that means that the exponent is a 1. So 2 times 1 is 2. So now we're going to have 2 to the second power, or 2 squared. And 2 times 2 is 4. But for this one, it's like you put the 2 in here and that cancels the 2 for this one. So you will just end up with y. Why? Because that means 2 times 1 is 2, and then 2 times 1 is 2. Okay, so for this one, 2 to the second power is 4, and this cancels, so you just end up with the y. Then what we're going to do, if we're adding 3y, we're going to subtract 3y from both sides, and you get 2 is equals to 4y minus 3y, y. And that's the answer for y. Now remember that for radicals, you always have to check your answer. And so we're going to substitute the 2 in both y's. So the square root of 3 times 2 plus 2, is it equal to 2 times the square root of, instead of y, we put 2. And so in here, 3 times 2 is 6. 6 plus 2 is 8. And on this side, we bring it down the same way. Now, you can go on both directions. You can multiply this or square it and put it inside of the square root. Or you can actually simplify this side, which I think that's what I'm going to do. So in here, what you do is you do prime factorization. 2 times 4 is 8, and then 2 times 2 is 4. Because this is a square root, we need a pair, and remember that this goes outside, only one of each pair, and this stays inside of the square root. So it's 2 times square root of 2, and we just bring this down, and we notice that it is the same answer, so we say check. No, I was going to leave it like that, but you know what? I think I want to go the other way. What if we decide, instead of simplifying, to making this into a square root? So we know that 2 is the same as the square root of 4. Right? Why? Because the square root of 4 is 2. And bring this down. All I'm doing is making that into a square root. Square root of 4 equals 2. Bring this down. And now this means multiplication. So whenever you have multiplication inside radicals, all you do is 2 times 4 is 8. And bring this down. So again, whichever you change or manipulate, you will end up with the same on both sides. Okay, so we say check. Number 2, what we're going to do again is to square both sides. This cancels, and so we get 2x plus 1 equals x plus 5. Now, because we don't have any more square roots or squares, all we do is get rid of the x in here. And this cancels. 2x minus x. X, bring down the 1. Bring down the 5. And we subtract 1 from both sides. And so x equals 5 minus 1 is 4. For the checkup test, we substitute our x with 4. And so the first one is 2 times 4 plus 1 plus 1. Is it equal to, inside of the square root, 4 plus 5? And we simplify that. So 2 times 4 is 8, plus 1 is 9. 4 plus 5 is 9. And you already see that, yeah, they're the same. So the square root of 9 is 3. Same here. So check. So this is a true solution. It's not an extraneous solution because they come up equal. Okay, for number 3, you can see that you have variables inside of the radical and outside of the radical. So the first thing that we're going to do is to get rid of that radical by squaring both sides. And so this cancels, and so we get x squared minus 5 equals. Now, because we have a binomial, some people will say, oh, x squared plus 25, but no. In here we have to be very careful because it's a perfect square. And you can do the shortcut of a squared plus 2ab plus b squared, which is square the first term, so it's x squared, multiply a times b and twice that, so x times negative 5 is negative 5x times 2 is negative 10x plus b squared. B squared is negative 5 times negative 5, which is positive 25. But if you get confused with that, what you can do is just do FOIL. When you have x minus 5 square, it just means multiply that times itself 2 times. And so you do FOIL. First is x times x, which is x squared. X times negative 5 is negative 5x. Negative 5 times x is negative 5x. And negative 5 times negative 5 is positive 25. And when you combine like terms, you get x squared, which is right here. Negative 5x plus negative 5x is the negative 10x, and positive 25 is right there. Then what we're going to do is to subtract x squared from both sides. This cancels, but we notice that that happens on the other side as well. I get negative 5 equals negative 10x plus 25. The goal is to leave x by itself, so we subtract 25 from both sides. That cancels, and you get negative 30 equals negative 10x. Finally, if we're multiplying, the opposite is to divide. Remember that in division, you divide with the same sign. Okay, so that cancels, and you get x equals negative divided by negative is positive. 30 divided by 10 is 3. But remember that whenever we're dealing with radicals, we have to check to make sure that the answer is correct. So 3, we substitute that in here and in here. So it's going to be square root of 3 squared minus 5. And we say, is it equal to 3 minus 5? And square root of 3 squared is 9 minus 5. Is it equals to 3 minus 5 is negative 2. 9 minus 5 is 4 inside of the radical. Bring this down. The square root of 4 is 2, which is not equal to negative 2. Okay, they are opposite of each other. So we say that this is an extraneous answer or solution. It's not a true solution, and it's EX, not S. Okay, for number 4, again, we start by canceling with the square. That square cancels the square root, and same on the other side. So we get 4x minus 3 equals 3x plus 4. We subtract 3x from both sides, and we get x minus 3 equals 4. Finally, we're subtracting. The opposite is to add 3 to both sides, and x is equals to 7. Again, we have to check by substituting the x with the 7. So 4 times 7 minus 3 inside of the square root, is that equal to, again, we start with the square root of 3 times 7 plus 4. And so 4 times 7 is 28. 28 minus 3 is 25. Is it equal to 3 times 7 is 21, plus 4 is 25. So we say that the square root of 25 is 5, which is equals to the square root of 25 is 5. And yes, they are correct. So this is a true solution. Okay, for number 5, we have both variables inside and outside of the radical, but we also are working with fractions. I don't want you to be scared of fractions, and I will work with the fractions so that you continue to practice that. And so we square both sides. This cancels with the square, the radicals cancel with the square, but on the other side again we have a binomial. Okay, and in here we have x plus 4, but in here we have 1/2 of x plus 2 times 1/2 x plus 2. Now if I go directly, a squared is just 1/2 of x times 1/2 x will be 1/4 x squared. When we multiply this and multiply times 2, 2 times 1/2, it just means 2 halves. It's a whole. So 1x times 2 will be 2x. And then b squared is just 2 squared, which is 2 times 2 is 4. Now let's do it with the FOIL, or this double distributive property. 1/2 times 1/2 is just 1 times 1 is 1. 2 times 2 is 4. Remember that in multiplication we just multiply straight for the fractions. And x times x is x squared. For the next one, which is outside, the two terms outside is 1/2 times 2. Remember that when we have a fraction and a whole number, you just multiply the whole number times the numerator and divide. So multiply and divide. 2 times 1 is 2. 2 divided by 2 is 1x. Do we need to put the 1x? Let me just put it, you don't need to put the 1 as a coefficient. Then inside, if you notice, it's exactly the same. 1/2 x times 2, same here. 2 times 1/2 x, you will get 1x. Okay? Why? Because 2 times 1 is 2. 2 divided by 2 is 1. And then last, 2 times 2, which is 4. We combine like terms. So 1/4 of x squared. 1x plus 1x is 2x plus 4. Okay, you notice that we get the same thing. So now what we're going to do is subtract 4 from both sides. And we can also get rid of that x at the same time. So minus x, that also cancels. You get 0 is equals 2. We bring down the 1/4 x squared. 2x minus x is x. And at this point, you can decide whether you want to use factoring or you want to use the quadratic equation. I think it's easier if you just factor out the x. Both terms have x, so that will be your factor. 1/4 x squared divided by x is 1/4 x. X divided by x is 1. And we bring down the 0. Now in here, whenever we have only one term with an x outside, that means that the value of x will be 0. Why? Because it means a factor multiplied by another factor equals 0, so one of them has to be 0. For this to be 0, you just put x equals 0. Or for the next one is the opposite. If we're adding 1, the opposite is to subtract 1 and divide it by the coefficient of x, which is 1/4. Whenever we have a whole number or integer divided by a fraction, we put it over 1 and then we multiply. -1 times 4 is -4. And 1 times 1 is 1. And so -4 divided by 1 is -4. Now we have to check to make sure that these are not extraneous solutions. And so let's check 0 and -4. So we have 1/2 times, let's do 0 first, plus 2. Is it equal to the square root of 0 plus 4? 0 times 1/2 is 0, plus 2 is 0 equals to the square root of 0 plus 4 is 4. And the square root of 4 is 2. 0 plus 2 is 2. So yeah, 0 is a true solution. Okay, now let's check -4. And so 1/2 times -4 plus 2, is it equal to the square root of -4 plus 4? And so in here, again, remember that when you're multiplying a whole number or integer times a fraction, you multiply -4 times 1, -4 divided by 2 is -2. Bring down the plus 2. In here, -4 plus 4 is 0. And -2 plus 2, they're opposite, so they cancel each other. And in here, the square root of 0 is 0. So yeah, that's also a solution. So both of those are true solutions. Okay, 0 and -4. Okay, let's do one last one, number 6. Again, we square both sides. And these cancel each other, so we have x plus 3 equals, again, square root of the first one is x squared. Multiply this and then times 2. So x times -9 is -9x times 2 is -18x. And then b squared is -9 times -9 is +81. Again, if you want, you can check by doing the double distributive property or FOIL. And so you can do that on your own. You should get this same thing. So now what we're going to do is we're going to cancel -x and -3. Let's take both at the same time. -x, -3. I was going to do it in here, but remember that we have to align it with a similar term. We get 0 equals, and here it shouldn't be there. And so we keep the x squared. -18x and -x is -19x. 81 and -3 is 78. You can decide to use factoring in here or the quadratic equation. It's up to you. But what we need is two numbers that when we add them equals -19. So, and multiply is +78. For them to be positive, both of them have to be this sign. So both are negative. So what are factors of 78 that add up to 19? The easiest one to find first is 9 times 10. Both are negative, right? And 9 times 10 is equals to +90. That's too big. It's not 78. And what are the other ones that add up to -19? Well, what about -8 and -11? That's +88. So no, -7 and -12. That's 7 times 2 is 14, carry 1. 7 times 1 is 7 and 1 is 8. No, but we're getting closer. Let's see if we can find it. -6 and -13. So all I'm doing is subtracting 1 from here and adding 1 in here. But in the negatives, okay? And so negative times negative is positive. 6 times 3 is 18, carry 1. 6 times 1 is 6, and 1 that you're carrying is 7. So it's 78. That's your factors. Those are your two factors. 0 is equals to, we open parentheses, xx, and you have -6, -13. But that's not the value of x. Remember that the value of x, these are two factors that equal 0. For that to be 0, you need a +6 so that when you subtract 6, you get 0. Or you need a +13 because +13 and -13 is 0. Now, these are solutions, but are they true solutions? Let's check. So we are going to substitute into x plus 3, substitute with 6 first. So 6 plus 3, is it equal to, 6. 6 is our solution. 6 minus 9. And so in here we get 6 plus 3 is 9. Is it equal to 6 minus 9 is 3? Negative 3, because the biggest one is negative. The square root of 9 is 3. And we say that they're not equal to each other. So no, they're not. That's not a true solution. Now let's try the 13. Again, we're substituting the 13 in here and in here because those were the value of x. Okay, so the square root of 13 plus 3, is it equal to 13 minus 9? In here we get 13 plus 3 is 16. 13 minus 9 is 4. The square root of 16 is 4. So we say check. So 13 is a true solution, but 6 is an extraneous solution. And 13 is a true solution. With this, we end our lesson. If you can please give us a thumbs up, subscribe around here. This is the link to the entire unit, and here you will find the next video. Now you're able to do 5.2 and have fun.